Matilde have extra credit. Okay, you remind me, Matilde, always, okay? Okay, suppose I have to solve in this system. X plus 2y equals 7, and x minus y equal 4. Equation 1, equation 2. I like so much enumerate the equation and enclose the system in one big curly bracket, because this represents one mathematical object. Okay, together is a solution. Entonces, there are two methods for solving linear system of equations. One is substitution, one is elimination. One when you using one or another. Well, my recommendation is using substitution only when you have in the problem one variable with coefficiency 1 or negative 1. In this case, I see that the coefficients in front of the x is 1, and the coefficients in front of the y is negative 1. So we have reached, you take the equation 2, get the easier equation, you make a decision, solve for one variable, and the paper, I solve for x, and you substitute this expression in another equation, where in the x place, like that. But we have now x, no x anymore, no, sorry. It's 4 plus y plus 2y equals 7. And you solve this equation that contains only one variable, that is 4 plus 3y equals 7. 3y is equal 7 minus 4, que es 3, divided by 3. Es obvio que y is 1. Therefore, when you get 1, y equal 1, so you want to find x, use substitution here. Plug it in here. Y equal 1, so 4 plus 1 is 5. And the solution, this is x. Is the order pair 5,1. 5,1 is the solution. Que satisfy both equations. In the image I put in the left part, you see that, for example, the equation number 1, que is x plus 2y equals 7, corresponding with the blue color, and the equation x minus y equals 4 corresponding with the green color, and the intersection of both equations is the point 5,1, que is the common point. And always happen when you have a system in 2 dimensions and touch or crosses in one point is the solution. Okay, so far it's okay. Everyone follow me? No problem? No?
No.
Okay, erase the board?
Yes.
Okay. Okay, let's go to example 2, que bring me new situation. Example 2 is, well, ax minus 2y equal to equation 1. And 4x minus y equal 5. Equation 2. This is the system. We can solve it by substitution. Yes. Why? Because y is isolated, waiting for me to use that. So you take y, so you copy 4x minus y equal 5. You solve for y, 4x minus 5 equal y. And now substitution, this expression in another equation, in the y place, is this. Here. We have the ax minus 2 times something, and you replace the y for this expression, the 4x minus 5. Equal to. You distribute it. It's ax plus 10 equal to. Wow, something weird happened here. The x is cancelled. I cannot solve it. And you get a contradiction, 10 equal to. When you get this condition, it's because we have no solution. No solution. Okay, you try to do your best. Okay, and you cannot solve for x because disappear the x in the equation. And you get a statement gets completely false. And the interpretation is a no solution. If you want to see geometrically what is the interpretation of this, well, let me try in the PowerPoint. In the PowerPoint, in the second page of the PowerPoint, do you see the interpretation of this? Look at that. This is the same system, but this two parallel line. And the two parallel line never has common point, therefore no solution. So the interpretation in two dimensions, you know, in two dimensions, each equation represents line. Entonces now, no solution is because this line never meet, never cross, never touch. We have no common point, so we have no solution. Good? Everyone follow me? No problema? Okay, a review, pero little by little I want to complicate like a pre-calculus, no? Example 3. Example 3 is 3x minus y equal -2. Equation 1. I want to put the number of the equation because when you have a complicated system in which you have not two equations, you have three equations, four equations, it's important call the name. Equation 1, equation 2, equation 4. But in this case, no, it's easy, two equations only. 6x minus 2y equal -4. Equation 2, and it's my system. Okay, nice. One more time, I can do by substitution because I see that this y, the coefficient is -1. So I take this equation, 3x minus y equal -2, and you solve for y. 3x plus 2 equal y. Now, you take this expression and substitution and then another equation in the y place here. Entonces, 6x minus 2, parentheses, no y anymore, it's 3x plus 2 equal -4. Therefore, apply distributive, 6x minus 6x minus 4 equal -4. Again, happen that this is cancelled out. Wow. But it's different because you get true statement. Look, -4 is equal to -4 is true, and the interpretation is different. The interpretation is we have infinity many solutions. So this system is consistent. This system has solutions. The problem is that you have no only one, no unique solution, you know, infinity many solutions. And the idea is super clear because the equation 1 and equation 2 is the same equation. Because if you multiply the equation 1 by 2, let me show you. If you multiply, we're using that notation always, guys. Multiplication by 2, this equation is 3 times 2 is 6, -1 times 2 is minus 2y, is equal -2 and +2 together, 4, and this equation is the same as the equation 2. So you prove, you multiply any equation by one number, the entire equation by one number, you are doing nothing. It's the same. You see different, but it's the same equation. No? So now when you are doing the graph, it's the same graph. Are you clear that the same or no? Are you clear?
Yes, it's clear.
Yes, you're clear que es the same. Okay. Entonces, bueno, okay. You are rich. We have infinity many solution. But what is the infinity many solution? Is all real number? No, it's no real number. No. Wait. Let me explain. Let me try to explain. Okay. See you, for example, you take the equation 1 and you solve for y. You copy 3x minus y equal -2. You solve for y is 3x plus 2 equal y. I did before that part. Okay, nice. And you take the equation 2 and you do exactly the same or similar. 6x minus 2y equal negative 4. And you solve for y is 6x plus 4 equal 2y divided by 2, because you want to isolate the y, is 3x plus 2 equal y. Wow, you see it's the same? This and this is the same line. Okay? Well, okay. I understand this. However, I don't understand very well how you represent infinite many solution. Well, it's a line, I know. And another is the same line. Entonces my question is all real number? No. No. In the first place, because we are working in 2 dimension, 2D. And this point is no solution. 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 It's only solution, the point on this line. Okay, and by the way, it's the same equation. So how you write solution set? Well, you're using new idea. Is the order pair x comma y, like the blue color, such that, for example, there are relationship between x and y. There are many ways to define that. You take the equation 1, you take the equation 2, you solve y, you solve x. I prefer take the Easter equation and you solve for y, like that. And you copy this. This is y such that is equal to 3x plus 2. And you declare, comma, the x is all real number. And this represents perfectly this line. Any point on this line. Is the only way to do that? No. No, it's the only way to do that. Another possibility is the order pair x comma y such that, and instead of solve for y, you solve for x. And to say super easy is 3x equal y minus 2 divided by 3. So x is equal y minus 2 over 3. And you declare that y is all real number. Is all real number. It's the same idea. Expressed in different way, but it's the same idea. It's the same line. Entonces, this variable, que es all real number, is normally called free variable. And we have free variable only in the case that we have infinite many solution. Okay, when you have infinite many solution problems, is when you have free variable. In 3 dimensions, it's more complicated because sometimes we have not only one free variable, we have maybe one free variable or 2 free variables in 3. In 4 dimensions, it's more complicated. But relax, we are doing step by step. The most important is to understand the idea. So when you solve the system of equation, we have 3 possibilities. Unique solution. What is unique solution? This is the most popular. Is when you have 2 lines, you have only one intercept point, unique solution. Okay, the name of this system that satisfies the condition is consistent. The word consistent indicates we have solution. Si es inconsistent, no solution. Consistent and independent. Independent means that the graph of the equation 1 is completely different the equation 2. This is mean independent. We have another possibility que es parallel line. Entonces es obvio que es inconsistent. No solution. Es equivalent. Es sinónimo, ¿no? No solution and inconsistent is the same thing. No solution. Because we have no common point, but the graph is independent. Independent because the graph of the equation 1 and the equation 2 is not completely, but it's different. It's different. It's the same slope, but it's different y-intercept. Look, this is the y-intercept for this. This is the y-intercept for this. And the third scenario is infinite many solution. No? In this case, you have the equation 1 is equal equation 2, the same graph, ¿no? Entonces es obvio que es consistent. Es consistent because the word consistent indicates solution, not solution. This is solution. We have solution. In this case, yes, we have infinity, many solutions. But it's dependent. It's dependent because the graph is equal. Okay? This is the idea in 2 dimensions. Let's do one more example in 2 dimensions because I want to explain one new situation. I can erase the board or no?
Yes.
Yes or no?
Yes.
Yes.
Yes, Professor.
Okay. In this example 4, I want to illustrate the other method I prefer. I prefer elimination. Substitution is using only when you have one equation que contain coefficients of 1 or -1. But the majority of the example, no. We have no coefficients of 1 or -1. We have another coefficient. This is example, so I prefer doing by elimination. This is my first equation. Equation 1. And this is my second equation. Equation 2. Okay, as the system is given, I need to solve. There are many ways to solve this, but we are using elimination. And inside the elimination, we have different possibilities. Okay, entonces I need to make a decision. No? I don't want to do no infinity, but we have several. I don't want to do in any way. No. One student select one way he consider it better, another student no. In my opinion, what is the idea behind elimination? Well, I need something. Suppose que has negative 12y and positive 12y. And when you add in this is 0. So it's elimination. It's the idea for the elimination. I need to create artificially, of course, one variable can have one number and another have the same number but opposite sign. I take advantage that this is negative and this is positive. So I multiply the equation number 1, the entire equation number 1, I multiply by 3. And the equation number 2, I multiply by 4. Okay, this is the symbolic way that I create for denote this idea. So when you are doing multiplication, okay, let's do it. You multiply, you have 9x because 3 times 3 is 9, no? Minus 12y equal 3. Nice. And this is my first equation number 1, que you know very well, que is equivalent to the equation number 1 original. Because when you multiply one equation by one number, nothing happens in the graph. Stay the same. Okay? Likewise, you multiply equation number 2 by positive 4. So we have ax plus 12y equal 48, no? 48 gets the multiplication, 12 times 4. Now ready for elimination. You adding by column. The column of the x, 17. The column of the y, cancel out. That's no surprise. I did with this intention, no? And this is 51. Divided by 17 both sides. X is equal 3. And remember, I need to find x and y. Therefore, this x value, use substitution in either equation. What the equation? Well, the equation that you consider easier. In my opinion, my personal opinion, some students say different like me, use substitution in the first one. So 3 times 3 minus 4y equal 1. 3 times 3 is 9. Negative 4y is equal 1 minus 9 is negative 8 divided by negative 4 both sides, y is 2. Therefore, the solution is the point. Solution you express like order pair, 3, 2. Any question? No problema. Everything is clear. Very, very clear.
Clear.
Now let's move on to the three dimension. Three dimension, you see maybe in Cole algebra, but not too much detail. You see in Cole algebra three dimension? Yes or no? Come on, help. Answer me. You see in Cole algebra or no?
No, I don't think so.
Okay. No. Okay. Some teachers don't explain this part. Some teachers explain, but not too in detail. Okay, in three dimension, we have three equations and three unknown. Okay, I want to call X, Y, and Z. Okay, suppose this. Okay, this is the system gets given. It's given like that. Okay, three equations, three unknown. Unknown X, Y, and Z. Variable. And three equations. Three equations and three unknown. This is a problem 3D, three dimension. Three dimension because the representation of this, you see it after. No, now. Each equation is no line. No, it's a plane. So the representation, each equation in 3D is a plane. So we have a famous 3D space, X, Y, Z. This look like in 3D like a corner, no? Corner of the something, no? And the representation of the equation is a plane like that. Don't worry because the graphic in 3D is not your problem. However, I want to teach a little bit. We have software, not Desmos, another software that allow us to compute the or to do the graph in 3D. But no, this is not a problem now. The problem is solution. Find the solution. CS1 solution, CS infinite dimension solution, or no solution, or we have free variable or no free variable. This is the challenge now. What is the organization? Please pay attention que es not hard, pero es systematic and you need to do it that way. You pair two equations. For example, I want to pair equation 1 and equation 2. Why I do that? What is the clue that give me information that this is a fantastic combination? Because equation 1 and equation 2 has ready elimination in the y part because it's negative 3y and positive 3y. Not always this is happening, but I create this example to make easy the understanding that part, no? Another example is you need to create that. But okay, this is the idea. Entonces now you add in plus 1 plus 2 is 3 elimination. And this is 3 minus 1 is 2 equal 11, no? Because 15 minus 4 is 11. And I call equation number 4. Equation number 4. And this equation is a little bit different because contains two variables, two unknown. I eliminate 1. And you pair now two equations. I pair 2 and 3. But what is the reason I make a decision to pair 2 and 3? Equation 2 and equation 3. Look. Well, because in the second couple of the equation, you must mandatory eliminate the same variable. So you eliminate y in the first couple, you need to eliminate y in the second couple. And this is already done in that part. Okay, do you see another example? It's not too easy. This is the elementary example that I create to explain the first example in 3 dimensions. But in general, no, not necessarily happen that. This is 6. This is cancel. This is minus 2z. -1, -1, no? And this is 34. And this is equation number 5, no? We have 4 and 5. And you put 4 and 5 together, because now we have a systems that contain only 2 unknowns, similar to the 2-dimension problem, no? Okay, but this example is fantastic, because again it's ready elimination C, no? And you see can cancel out that part? No, no will happen this, I promise. And this is 9, and this is 45, no? And divided by 9, oh, if I get x is 5. I need to find y and z. To find y and z, we're using the original equation. No, never, because the original equation contains 3 variables, and we have in my hand only 1. So in my opinion, it's better using 4 and 5. I prefer 4 because it's easier. It's 3 times 5 plus 2z equal 11. This is 15. Plus 2z equal 11. 2z is equal 11 minus 15. 2z is equal to -4 divided by 2. C is -2. Well, when you have 2 values in your hand, it says you can select either 1, 2, 3. I select, I have no idea, I select 1. Because I consider it good. Entonces, x es 5. Use substitution 5. Minus 3y, que I have no idea who is y. Plus 3z, que is 3 times -2. Be careful with the signs. Equal -4. Beautiful. Entonces 5 minus 3y minus 6 equal -4. Positive 5 and -5 is -1. We continue here. Minus 3y is equal -4 plus 1. Minus 3y is equal -3, no? Yeah, -3. And divided by -3 both sides, it's obvious that y is 1, positive 1. So we have one solution, unique solution in the 3-dimensional space. And the solution we can represent like a point in 3D. And the point in 3D have 3 components, x, y, and z. Now you represent like a triple order, like that. 5, 1, -2, exactly in the alphabet order, x, y, and z. Any question? Any question? This is the way. You pair 2 equations and eliminate 1 variable. You pair another equation and eliminate the same variable. So you eliminate another, you are in big trouble. Okay? Do you follow me or no?
Yes.
Okay. However, let me see. Okay, in 3 dimension, the thing is very complicated. Look, let me show you. We have more possibility. And when you increase the dimension of something, we have more possibilities. Okay, in this picture, you can see not all, but a lot of possibility. This picture. Let me insert that picture. Wow. Okay. In this case, you see, wow, what the hell is it, professor? Well, this is the using your imagination is the interpretation, no? Okay, you have 3 planes, red, yellow, and green, on different positions. It's a 3 dimension. Each plane represents equations, right? And remember, the solution is the intersection. When you have When the plane touch, we have solution. Pero si touch in one point is one solution. Pero si touch in several points, like a line, es infinity many solution, no? Entonces, for example, let's do in this. This scenario. This one. We have solution or no? So we have three planes, totally parallel. We have no connection, no? Yes or no? Solution or no solution?
No solution.
No solution. He said no solution. Everyone is agree or disagree? No solution.
Yes.
No common point. What do you think about the second scenario? We have solution or no? Wow, what the hell? All right, let me erase that part. Erase. Okay, in the second scenario, solution or no? This one. Solution. Pero one solution, unique or infinity many? Solution.
One solution.
Everyone is agree with her? Only one? I mean, I hear something, but I hear bad. Come on.
Infinite solution.
Infinite solution means because this plane have in common one line. Look, any point of this line, two, a solution. Therefore, we have infinity many solutions. Yes? You see much better now? Yes or no?
Yes.
Okay. I want to take advantage this moment to see one. Okay. Entonces, when you have infinity many solution, the professor explained that we have free variable. So es the variable que yo declaré all real number, no? In this case, how many free variables you suppose that we have? Entonces, the interpretation of this is, si es a line, si the solution is the line is a geometry object que have one dimension. Therefore, we have one free variable. So when you write this solution, que by the way is infinity many solution, but this is an incomplete answer, we need one free variable. And the reason is because the object is one line. And one line is the object que have only one dimension. What do you think about this guy? Solution or no solution? The third one.
Solution.
Everyone is agree with her?
Yes.
Yes.
You are totally wrong. Because we need the common part, but in between the three equations. I know very well that we have solution here in between equation yellow and equation red. And here in between equation yellow and equation green. But what is the common point between yellow, red, and green? No common point. No solution again. Do you see or no? Yes or no? No, clear?
Yeah.
Clear. What do you think about this scenario? Solution or no solution? Solution or no solution?
No solution.
Absolutely. You're right. And the last one, this one. Solution or no solution?
Solution.
Yes. In this case, only one point. Look, that point. Okay, because, for example, in between the equation red and equation green, we have a line, this line. And the intersection between this line and the plane yellow is this point. In this case, unique solution. Okay, so we have a similar idea. We have solution, no solution, infinity many solution, but the complicated part is now, can you determine the amount of free variables? See one free variable, see two free variables, but you don't worry because you see in the example. So you don't understand very well this part now, and the example, I promise you can see. Okay, before start new example, I want to illustrate one software that we use throughout the semester. Que es no Desmos, it's Geogebra. Let me show you. Let me show you Geogebra. Switching to Geogebra. Geogebra is science fiction. It's science fiction. Do you see Geogebra? Do you see
Yes.
Geogebra? Okay, look. Okay, this is the equation. I delete the equation, I delete everything. This is my three-dimension space. The red color axis is the x-axis. The green is the y, and Z is blue. And you can plot here equation by equation. Okay, this is equation 1, it's a plane. Equation 2 is another plane. This plane touch intersecting. And we have another plane, it's another equation. Bam! And I can see in that corner, you see in that corner, is common point. Look, I put the point, I put it in black color, look. Okay, this is solution for the system. That point, okay, it's 5, 1, -2. No? We get this answer, the problem. I don't remember. Let me see in the paper. Yeah. 5, 1, -2. Okay. Entonces they are different versions. This is similar to the Desmos. Is you don't need to download anything in your computer. Is you can work in the cloud. I recommend you create another account using email address and password. I recommend, I highly recommend, because using not necessarily in this chapter. We use it throughout the semester in another more complicated thing. We use Geogebra. Geogebra is the work, is the connection of the algebra and geometry, no? Together, Geogebra. Pero Geogebra, the version classic. I want to write in the whiteboard. Let me switch into whiteboard. Okay, the name of this software is you see whiteboard?
Yes.
Okay, it's Geogebra. You go to the geogebra.com, create the account and open. Classic. Because there are different versions. Geogebra only for the geometry, only for the algebra, only for the calculus. So you apply classic, like a basic. In my opinion, the environment is super fantastic. You see that? It's super fantastic, right? No, but no, now. You open at home. I promise you we continue working this. Okay, suppose next example. Okay, next example is minus x plus 6y minus 3z equal negative. Equation 1. X minus 2y plus 2z equal 3. Equation 2. And the last equation is 3x plus 2y plus 4z equal negative 6. Equation 3. And this is the system I need to solve. Well, remember, there are many ways to do that. One student solving different to me, but the beauty, of course, we get the same answer. So in the solution, I pick equation 1 and 2 because I see something interesting. Okay, x is positive and negative. Same coefficients, nice. I take advantage of this. It's equation 1, I copy again. The organization is extremely important. Okay, you are in equation 1 plus equation 2. And the action here is equation 1 plus equation 2. plus here. This elimination is gone. This is 4y minus c, because it's negative 3 and positive 2 is negative 1, and c equals negative 5. And this is my equation number 4. Okay, stop here for a moment. I pair now equation 2 and 3. Not necessarily it's always the same, guys, but when I make a decision this. Equation 2 again, I copy, and equation 3. I create this example intentionally to illustrate this idea. I want to explain that. And you see, wow, it's ready for elimination of the y bar, right? Because it's negative 2 and positive 2. No, this is wrong, because you eliminate x in the first couple, and you need to eliminate x also in the second. Okay? If you multiply, well, let's do it. How we were doing? Well, you multiply the second equation by multiplication by negative 3. Okay, when you multiply the entire equation number 2 by negative 3, we have negative 3x plus 6y minus 6z equal negative 9. And this is also my equation 2, of course, present in different way, but it's the same. Okay, now ready for adding 2 plus 3. Of course, the new 2, not the old 2. Elimination the x, this is ay, this is negative 2z equal negative 50. And this is equation 5. It's equation 5. Okay, okay. Okay, now 4 and 5 together. 4 and 5 together. I have ay minus 2z equal negative 50. Equation 5. Okay, entonces we pay attention, we focus it in this equation, no? 4 and 5 only. Okay, entonces now, in order to make elimination, maybe you multiply equation 4 by negative 2, no? So you multiply this equation, multiply by negative 2, because I want que 4 multiplied by negative 2 is negative ay, negative 1 and negative 2 and positive 2z, and negative 2 and negative 5 is positive 10, no? And this is my equation, new equation 4, and now 4 and 5 together, so 4 plus 5, the new 4, of course. This is cancel. Wow, this is cancel. Everything is canceled. No, no, everything, no. This is negative 5. And we get contradiction, get completely false. And that indicates us that we have no solution. No solution. So we're gonna. We have no solution. So that means that this triplane, you want to see geometrically in Geogebra, well, we can. Of course, we can. We can. Any question? It's similar, right? Similar to the 2 dimension. You get the contradiction, disappear a variable, and you get the contradiction, so that means no solution. So this equation have no common point. Okay. Good, very good. One more example. Oh, 2 more. 2 more. May I erase the board or no? Am I doing it too fast or no?
Yes.
Okay. Okay. Let me erase the board. This is example, new example in which, for example, the first equation is only 2x plus y equal negative 3. This is equation 1. The second equation is 2y plus 16z equal negative 10, equation 2. And the last equation is minus 7x minus 3y plus 4c equal 8. Equation 3. Okay, I create this example intentionally, no? Because sometimes happen that one variable is missing in one equation. But you don't care. This is normal. No problem. Not always is happy. It's completed. No, sometimes it's missing. Well, okay. But the procedure is the same. For example, you take it, the equation 1 and equation 2. What is my intention? Well, okay. My intention is, I take advantage of this idea. What is the only variable that's common in the 3 equations? Why no? It would be fantastic to eliminate y. This is the strategy. Okay, then you take the equation 1, is 2x plus y. C is missing. So you want to keep the order of the column, you put 0c equal -3. This is my equation 1. And the second equation I take to pairs. But the number 1 is number 2 is no x, no y, 2y, 16z equal -10. Equation 2. Okay. Entonces I see que the y is the variable que I should delete somehow. Entonces now your multiplication, the equation number 1 by -2, no? You multiply by -2, we have -4x, we have -2y, we have 0c equal positive 6. And this is my new equation 1, gets equivalent to the original equation 1. It's the same plane. Okay, when you combine together is -4x. This is cancel out. Good. This is 16c equal -4. Well, this is equation 4. You leave it like that, you can, why not? But I saw that any coefficient is 4, 16, and 4, no? Entonces, you can divide by 4. This is not mandatory to do. However, I highly recommend divide by -4 or by +4, either way. When you divide by -4, here everything -4, -4, -4. Well, my new equation 4 is x minus 4c is equal 1. Wow, easy. This is my equation number 4. Everyone follow me? Guys,
yes.
this is important.
Yeah.
Organization is extremely important, you know. And keep it order. Okay, horrible. Now, I take equation 2 and equation 3. Equation 2 and equation 3. Equation 2 and equation 3. Okay, I copy again equation 2. Equation 2 is 0x plus 2y plus 16c equal -3. This is equation 2. And equation 3. Well, I take -7 minus 3y plus 4c equal 8. Equation 3. I need to do something, transformations, in order to eliminate the same variable que y. Here. Entonces, the strategy I used was multiplication, this equation by 3 times 3. And this equation by 2. Because I take advantage that the sign is opposite here. So when you are doing that multiplication, of course, it's 0x plus 6y plus 48c, 48 come from 16 times 3, no? equal negative 30. And this is my new equation too. Okay, nice, I like that. Now multiplication by 2, number 3 equation is negative 14 x minus 6y, because the 2 times 3 is negative 6, plus az equal 16, no? Because 2 times a is 16. And this is my new equation 3. But it's ready now for elimination. 2 plus 3 by column. The negative 14, this is cancel out. This is 56. 48 plus 8, and this is equal negative 14. And this is my equation 5. Okay, and this equation 5, I can see the coefficient 14 and 56 is divisible by 14, no? Yeah. Entonces, why no? I divided by this equation divided by, this is not mandatory to do, but it's okay. I like this way, no? Divided by negative 14. You divide by negative 14 here, negative 14 here, and negative 14 here. We have x alone positive, of course, minus positive divided by negative. 56 divided by 14 is 4, equal 1, positive 1. And this is my equation 5. And now you put together 4 and 5. Wow, something weird happened. You know, get the same. Wow, so what mean that? What do you think it happened? I'm confusing, really confusing. What do you think it happened? No solution or infinity many solution? I suppose you need solution. No. Because you need solution flow, easy. It's clear. When you have this complication, it's maybe you have no solution or infinity many solution. What do you think? Okay, when there's a contradiction, it's when you have two things is different. It's 4 equal 3, contradiction. When you have 4 equal 4, it's true statement, but we have no information to say it's infinity many solution. What do you think? Is infinity many solution or no solution?
Infinite.
Yeah. However, suppose the student don't know or don't know, realize clear this idea. Okay. I put together. I saw, wow, they are twin brothers, but I have no idea. Well, let's do something. For example, you multiply number 4 to do something. You multiply by negative 1, because my idea is elimination. No? So when you multiply by negative 1, you have minus x plus 4c equal negative 1. And this is my equation number 4 now. And when you adding 4 and 5 together, cancel out. 0 equals 0. 0 equals 0 is true statement. And always when you have true statement, is infinity many solution. Infinity many solutions. However, wow, okay, I understand. However, I don't know. No, I don't know very well how many free variable we have, because we have, when you have infinity many solution, maybe we are working in 3 dimensions, so maybe we have, okay, that mean, I don't know, it's a common line. It's no 1 point, no, it's no unique solution. I know, maybe it's the 3 plane have a line in common or a plane in common, so they are totally flat. No, totally flat no. It's one line in common, and the variable que disappear, que by the way is the y, is the variable que do not participate in the game, is the variable que do not participate in the solution, and you declare it like a free. O sea, si you try to write the solution set, is the triple order in the 3-dimensional space, such that, and you write the equation 4 or the equation 5, either way, you write the equation is x minus 4z equal 1, que is the mathematical relationship between x and c. But why do not participate in this game? Because it's cancelled always. That is the reason why it's all real, no? that the variable que do not participate in the relationship is the real, is the free variable. And so you are doing in Geogebra, you see that we have one plane, we have another plane maybe here, no. And the third plane we have here. And the solution is any point on this line. It's no unique, it's not only one, it's infinity solution, but the way to declare this in 3D is like that and using free variable. In this case, only one free variable. Okay, algebraically you see the y do not participate, and geometrically you see that is the line, and the line represents one mathematical geometrical object in one dimension. O sea, 0 dimension is a point, 1 dimension is the line, 2 dimension is the plane, and 3 dimension is the space, entire space, and so on. 4 dimension, 5th dimension. So mathematically we have possibility to navigate in more than 4 dimensions. But geometrically no. Geometrical only to the 3 dimension. Stop in 3 dimension. Okay. One more example. ¿Es clear or confusing?
Clear.
Okay. Let me see. Last example. Oh, no last. Next. Okay, this example is, wow, and you help me to understand this. X plus y plus z equal to equation 1. The other equation is 2x plus 2y plus 2z equal 20. Equation 2. And the other example is negative 5 minus 5y minus 5z, wow, equal minus 50. Equation 3. What do you think about this system? What do you think about this system? Remember, the idea behind this is that if you multiply or divide one equation by one number, doesn't affect the geometrical thing. It's a plane, it's the same plane. If you divide, you multiply by the same number, right? So you see in this example que es, wow, x plus y plus z equal to 2x, 2y, 2z equal 20. It's like somebody do the multiplication by 2, no? In the third one is negative 5, negative 5, negative 5, and negative 50. Somebody multiplied the first equation by negative 5. So what do you think about this system? No idea. Opinion, come on.
Infinite.
Open the microphone. Open the microphone, please. Come on, don't be shy. You say, si it's wrong, no problema.
Maybe in many solutions.
Infinity many solution. But why you believe that? Suppose que I using Open Geogebra, I am doing the graph of the first equation and look like that. This is the graph of equation 1. What do you think about equation 2 and equation 3? Is the same plane or is different plane?
Same plane.
Same plane. Very well. It's the same plane. So this is the graph of the equation 1, of the equation 2, and equation 3. So we have common point. Of course, we have every point on the plane is common. Of course, out the plane, no. But in the plane, yes. So we have infinity many solutions. You're right. Is solution set. Is all the point on this 3-dimensional space such that not all, no R3 is all the point in 3-dimensional space. No. Such that satisfy the condition. For example, you copy one equation to equation to equation. By the way, you know que es the same. X plus y plus z equal 10. I copy the first because I like, no? But you can copy the second or the third. It doesn't matter. And what about the rest of the variable? To say you, okay, listen to me. The solution is a plane. In the other case, the solution was a line. In this scenario, the solution is the plane. And the plane is one mathematical object que contains two dimensions. Entonces, we declare two free variables or two independent variables, ¿no? Entonces, for example, I select because I want, I don't know, I like selection X is good and Y and Z no, it's free variable. So you declare que Y and Z are a real number. This is the unique way to write. No. There are many ways to write this idea, but they are equivalent. Everything. Okay. For example, some people prefer isolate X, and the rest is okay. Or some people prefer isolate Y, and declare que X and Y and Z, sorry, are free variable. And we are talking about the same object as the display. Super clear?
Clear.
Okay, because I bring in the PowerPoint applications. You see what I understand solution. I am the expert doing that. I have no problem, but well, let's apply this in the real life, no? In the real life. That is the reason I bring the PowerPoint here. Okay, this is the first problem, application problem. Boom. Okay, this is actual idea of the coronavirus. Okay, in the hospital, using 15% bleach solution to disinfect a quarantine area. What means 15%? So you have container, suppose. And when you have 15% of the solution, que es the concentration que they need to kill the coronavirus that means that we have 100% is the total liquid, but we have 85% of water, pure water, and 15% is specifically the pure bleach solution, and together mix it is 15, no? This idea is clear, right? This idea is clear, right?
Yes.
Now I have three containers in my mind to understand this, because I need to create the 15% solution. Okay, I need that in the hospital using 6% solution. Get this guy, 6% solution. Look, it's not enough, but I need to increase it with the 18% solution to get the desired result. Okay, 50 liter of the 15%. Do you understand the problem now? Do you understand the problem now? Do you understand? No solution. Do you understand what the problem needs? Yes or no? No? No clear? Come on, guy.
No.
No. Okay. I need this container. This container has 50 liters of the 15%. I need that. I have in my hand 2 containers. And this container have 6%, no specification, the volume. No, because that's the thing I want to determine to mix it together. And another case 18%. Okay, called Y, volume. And when you put this together and the corresponding proportion, I have 15 liter 15. And make sense, you know, because when you mix it 6 and 18 together, the concentration that you get is intermediate value of 15. Make sense or not? Now.
Yes. Yes.
Excellent. Now, I derivate for these two equations. The first equation is the volume equation. The volume is x plus y is equal to 50. Makes sense, right? Because I don't know how many liter I need to mix it of the 6%, how many liter you get in the 18%. This is my first equation. My second equation is about specifically bleach. Volume and total. Contain water plus bleach. But we have one equation specific of the bleach. Que es multiplication by the concentration, que es 6x plus 18y is equal to the multiplication 50 and 15, que es 750. Do you understand very well this equation? Equation 2, equation 1, and equation 2. So actually, I should do a little bit different, but I like that way because actually this is percentage. And when you multiplication, you must convert to decimal. And you multiply this is 1, 2, is 7.5. This is my equation number 2, no? But it's okay. If you multiply this equation by 10, by 10, no, by 1,000, by 1,000, no, by 100, you convert this equation number 1 and this equation number 2. Do you understand the idea?
Yes.
And
Yes,
then,
yes.
entonces, I am ready for solving this system. I am ready. What do you prefer, substitution or elimination? What do you prefer, substitution or elimination? Remember, we are doing one problem in 2D. Easy. What do you prefer, substitution or elimination? And the question specifically said, I want to know both. How many liters? So X represent the liter of the 6% concentration container, and Y represent the liters of the 18% container. I need both to mix it together, okay? What do you recommend to do? Algebra. Algebra. I understand the problem. I set out the equation. This is the hard part. The rest is the easy part. Algebra. So I need to face this system. What is the most convenient way? Doing by elimination or substitution? Come on.
Substitution.
Substitution, she said. Why? I need a reason. Because, come on. What is the reason that you select substitution?
Because the first equation has one of the coefficients.
Exactly. This is the idea. She said because the first equation is one of the coefficients. So you solve for y or for x, either way. For example, let's do it. You solve for y here. Y alone. Sure. Y alone is 50 minus x. And substitution is expression here. So we have 6x plus 18 parentheses 50 minus x equals 750. Okay, super. Now you apply distributive property. Multiplication 18. I put in my calculator, of course. 18 times 50 is 900. 6x plus 900 minus 18x equal 750. And the recipe is okay. I subtracting, this is 12, no? Minus 12x, right there, no? Plus the 6 and negative 18. I move y now To the other side, 750 minus 900. Negative 150 divided by negative 12 both sides, because I need x alone, isolated totally. Okay, so 150 divided by 12. Okay, is in decimal 12.5. 12.5. And what is the interpretation of x? What is x? I don't remember. Let me come back to the problem. What is x? What is x? X represent what? Represent x. And what is the unit of this? What is the unit? Percentage? Dollar? What is the unit of that in this problem? Huh? Liters. Very well. Liters. It's liters. Liter of the concentration is 6%. It makes sense que es only 12 liters, no? Because the concentration in the Y container is Y equal 50 minus 12.5. Entonces 50 minus 12.5 is 37.5. 37.5 liters of 18. When you put this together, I guarantee you, these are these together, I guarantee you, que you obtain the thing you know, or you need, que es 50 liters of 15%. If you want to double checking, you can. Well, you adding 37.5 and 12.5 is 10 carried the 1 is 9, 10, 4 and 1 carried 50. And the concentration equation, well, okay, let's do it. You multiply 6 times 12.5 plus 18 times 37.5 should be 750. And you put in a calculator, wow, I get that. This is 75, this is 675, together is 750. It's true, this is checking, not mandatory. Okay, the answer I need is this and that. Any question? Super good or super confused? Okay, we continue next time, guys. Okay. Remember today. Wait, sorry. One thing I forgot to say. I am not clear. The student can subscribe my YouTube channel. But please, when you send me the test, you send me attach the subscription. Okay? You take a picture or something. I don't know. One way to indicate because when I saw my YouTube channel, I don't know very well. So I saw some students, but no, I do not identify. So I need to make
Professor,
fair.
I already sent the test by email, the written test, but I didn't send the subscription.
Bueno, you send me the subscription. You send